With the three-phase Pollard pillar drill converted to run off a single phase, two problems needed addressing. Play at the drill bit and 2 out of 3 auto-feed speeds not usable. As the auto-feed gearbox housing also supports the quill on the drill, this seemed the obvious place to start investigating. The handle on the gearbox cover, auto-feed gearbox, came away quite easily once a couple of pins had been knocked out of the handle. With the side off, you can see that there are 3 gears on the right hand side on the input shaft. These are for the 3 different auto feed speeds. Just to the left of that is the output shaft. The top of it is the driven gear from the lay shaft at the back, which is just visible with the gears moving up and down. That drives through a clutch, something similar to a motorcycle clutch, but it's a fail-safe clutch with just metal plates. It'll only slip if you hit something immovable. At this point the auto-feed gearbox couldn't really be dismantled anymore in place, so it was time to try and get it off. The whole gearbox slides up and down on the back pillar, and as you can see here, it's just come off the slide. With some support underneath the gearbox, there was a coupling halfway down that needed a pin knocked out. You can see here that the outer part of the shaft, the quill, moves up and down within the gearbox, but the drive shaft with the Morse taper end on the left rotates within that. To remove the fitting at the top of the quill, seen on the right here, a C-spanner was needed. And without one to hand, I had to make one up. There's a rattle here, which is actually play in the thrust bearing between the rotating shaft and the quill. With the quill now able to be somewhat reluctantly driven out, it eventually got to a point where the whole thing was going to overbalance as the centre of gravity had shifted, and it was time to take it from the actual drill and put it on a bench. This is the top of the quill, now it's on the bench. From right to left you've got the quill, a thrust bearing, a slotted adjuster for the thrust bearing, a similar lock nut for the adjuster, and the coupling for the drive shaft on the end. Another couple of C-spanners for these adjusters and lock nut had to be made up a different size again.
Let's try that.
Another roll pin had to be knocked out to remove the connector from the top of the shaft. Then the lock nut and thrust bearing adjuster unscrewed. then the thrust bearing taken off, which would finally allow the shaft to come out of the quill.
Right. That was stopping it coming all the way out. Take those off as well. Oh, what happened then? Oh, let's put it here for a minute.
The shaft just removed is the lower half section of the drive shaft, which ends in a Morse 3 taper. The quill is still in the actual housing.
So remember, when it comes to putting it back together, what we've got here.
Looks like there's a lip in there, isn't it?
Feels like a bearing.
Yeah. Here she comes. Great. There she is.
To remove the end cap on the bearing, I had to take a couple of pegs, insert them in the holes, and weld something across them. Oh, a nice roller bearing.
It didn't seem an easy way to remove the bearing race, and in the end I resorted to using an expanding collet and a slide hammer. There was a small groove behind the race, and the lip on the end of the expanding collet, when expanded, jammed into that, giving some purchase. At the top end of the quill was a bush that needed removing from the inside. This needed a drift of the right size that could be used to knock it out. this bush turned out to be quite worn, and as when the drill had been running, the drive shaft that stuck out the top of the drill could be seen to be oscillating from side to side. I wondered if this was part of the problem, so decided to make a new one. With the drilling mechanism out the way, the autofeed selector could actually be got at, and there didn't seem to be much wrong with that, apart from the housing in which the selector shaft moved, and replacing that was already part of the plan.